Okay, give me 10 minutes. I'm going to tell you how to express numbers in prime factor form. Most of the problems that people have in maths is understanding the question, not actually doing the question. Doing maths is pretty easy. Getting it is pretty hard sometimes. So let's have a go at this question. This is Taxis. It says express the number 60 in prime factor form. Now that's great, but if you don't know what a prime is and if you don't know what a factor is, you can't even start. So I'm going to start there. Right? So firstly, what's a factor? Right? The factors of a large number are just smaller numbers that go into that larger number. Right? In other words, you could divide a large number by a factor and you'll get a whole number. For example, this makes more sense with an example than anything else. Let's get the factors of 10. Factors of 10. Okay. So what can you divide 10 by? 2 times 5 is 10. So 2 and 5 are factors of 10. 5 goes into 10 twice, 2 goes into 10 5 times, right? 1 times 10 is 10. So 1 and 10 are the factors of 10 as well, right? I don't think there's anything else. You could divide 10 by 4, but you're not going to get a whole number. You could divide 10 by anything. You divide 10 by 7. Get on a calculator, you're not going to get a whole number. You're going to get a bunch of decimals. So they're not factors of 10. These guys are, right? So the factors of 10 are 1, 2, 5, and 10, and there aren't any more. I'll show you another one. Let's try 18. Factors of 18. Now every number has got 2 factors. Just like 10 had 1 and 10, 18 is going to have 1 and 18. So 1 and 18 are factors of 18, right? Every number has a factor that's itself and a factor that's 1, because 1 times itself is itself, right? No surprises there. But 2 times 9 is 18 as well. So 2 and 9 are factors. And 3 6s are 18 as well. So 3 and 6 are factors. And this is a good thing about factors. They come in pairs. Right? 2 times 9 is 18, 3 times 6 is 18, 1 times 18 is 18. They come in pairs of 2. So if you find one factor, you've automatically found the other one. All right. So they're factors. But what's a prime factor? Some of these factors are not prime numbers and some of them are. A prime number, keep in mind, a prime number can only be divided by itself and 1. Thank God I'm writing nice and neatly today. Right? So for example, 10 is not a prime number because it can be divided by itself and it can be divided by 1, but it can also be divided by 2 and 5. So 10 is not a prime number, but 11 is. The only 2 factors that 11 has are 11 and 1. You can't divide 11 by 2 or 3 or 4 or 5 or anything else and get another whole number. So that's a prime number. So they're factors and they're primes. So what's a prime factor? A prime factor, the prime factors of 18, they have to be factors and they have to be primes. So that's a prime, that's a prime, that's a prime. The other ones aren't prime, right? Now, if you have to express a number in prime factor form, that means you have to take that number and keep dividing it by other numbers until you get down to a list of numbers that are all primes. I'm going to show you with 60. In fact, here you go, 60. And here's the best way to do it. Leave yourself a lot of space down here. Right? We're going to go vertical. So here's the way to go. Pick any 2 numbers that multiply to 60. I'm going to go 6 and 10. Right? 6 times 10 is 60. And you keep on going until you can't break these numbers down anymore. Right? For example, 6 is 2 times 3. And 10 is 2 times 5. But these guys here are all prime numbers. I can't go down for another level. I can't say, I can't say that 3 is like 4 times 7 or something. It doesn't work that way because 2 can only be divided by itself and 1. 3 can only be divided by itself and 1. Same with 5. They are all prime numbers. Right? So that is expressing 60 in prime factor form. These are 60's prime factors. These are two other factors of 60, right? But these are the primes, right? And if you've done it right, then this number times this number times this number times this number will come to 60. 2 times 3 is 6. 6 times 2 is 12. 12 times 5 is 60. Got it. I could be a maths teacher one day. Excuse me. So they are the prime factors of 60. Now, by the way, this whole thing, that whole doohickey there, that's got a name as well. You often hear this. This is called a factor tree. Right? Starting with one number and dividing it by things and keeping on dividing it until you get all of its factors. And in fact, these ones are all their prime factors. But that whole thing is called a factor tree. So if you're ever asked to draw a factor tree representing the factors of something, that's what we mean. All right, I'm going to show you another one. Okay, have a look at this. Draw 3 different factor trees to show the prime factors of 36. Okay, we're going to do exactly what you just saw with 60. We're going to do it 3 times for the same number, and they have to be different. All right, 1, 2, 3. Now, when I started showing you this for 60, I said you pick any 2 numbers that multiply to 60. So we're going to pick any 2 numbers that multiply to 36. Okay, 2 times 18 is 36. I'm going to put the 18 over there. Doesn't matter where you put it, right? As long as they're together. And at every line, these 2 numbers should multiply to 36. Okay, 2 is a prime number. That's the end of that line. No more of this. 18 is 6 times 3. And 6 is 2 times 3. Now, they're all dead ends now, okay? So they are all prime numbers. We can't do any more branching of our tree, right? So they are the prime factors of 36. 2, 3, 3, 2. And again, if I've done it right, 2 times 3 times 3 times 2 should be 36, and it is. So we needed to do 3 of these, and they had to be different. So I'm just going to divide this by something different. I divided it by 2 here. I'm going to divide it by 3. Does 3 go into 36? Yeah, it does. 3 times 12 is 36. And again, that's a dead end. 12 is 6 times 2. 6 is 2 times 3. And again, you got the same 4 numbers. 3, 2, 3, 2. Pair of 2s and a pair of 3s, just like we got here. Right? You will get the same answer. This is why when you draw a factor tree to find the prime factors of something, it doesn't matter which one you end up with. Your friend might have drawn something different, but as long as you've got the same answers at the end of the branches, you've both got it right. One last go. 36. 36 is 4 times 9. 4 is 2 times 2. 9 is 3 times 3. And again, ta-da! Same 4. 2 times 2 times 3 times 3 is 36. There you go. That's factor trees, my friends. Thanks very much.